Maybe. So, step 2, comparing paths. Now that you've implemented the path class, you can try and create a priority queue path in order to build our algorithm. Gives an error. Let's move this over a little bit. In order to build, I need to be able to compare my elements, and Java has no idea, as they're seemingly unrelated objects from its perspective. If you check the documentation for the priority queue class, you can see it has multiple constructors. And the important one for us is the option to take in a comparator class. A comparator, as the name might imply, is a class designed to compare two objects of type E. Smaller. Does this by returning a number, a negative number. The smaller quotes a comparator has its own rules for what counts as smaller, meaning multiple comparators of the same type. Comparator string or string is positive. All right, so let's implement this. Psych. I think he gives us the code. He doesn't give us paths, though. Okay, psych. We do not have the comparator class. So I'll make that right now. We'll call it compare. I don't know, Java. Abstract class. Why you do abstract? A comparator path interface. What the fuck? The priority queue to output the shortest path, so you should base how the compare method works off of that. Comparator works. Uh, hmm. A comparator as a name. Nah, stop, bro. That's wild. How do you create a comparator class in Java? Say, yo, that's crazy. public abstract class compare. We'll delete that real quick. We'll quickly create a path compare Rator Java. And what we'll do is we'll implement compare Rator with path. Implements. Comparator cannot be resolved to a type. Public int compare path p1 path 2 if p1.length is greater than p2.getLength, return. So a negative number means the first object is smaller. So we're going to return 1. Else return 0. Method public class path comparator implements comparator path comparator with student. Yeah, I don't see what the issue is. Comparator cannot be resolved to a type. I'm gonna get water. I'll be right back. let's get back to it. So, okay, I just need this guy. Let's try that. Awesome sauce. All right. Equal. All right, so we have the path and the path comparator. So we can test this out in our main. Let's go ahead and do that. Where's our main? So we can load in a couple of locations and a couple of connections. Or just a couple of locations. So we've got a couple of locations here. Instead of giving them actual names, we'll just call them A, B, C, D, E, and F. So now what we can do is we can have a connection here. You know, the only thing is like, hold on, man. Connection. And we could say connection equals, and how do you make a connection? You give it a start and an end and a length. So equals new connection with A, B, and length 2.0. So I'm not sure how to use the outgoing connections iterable. I mean, array. Because we just made a path, right? A to B with a length of 2. And we can say, I don't know, we could say path equals new path, or I guess path 1 equals new path, give it an A. We can give it A, location A. And then we can say path 1 dot extend. We can give it connection. And so that means that our path 1 should be A, B, and have a length of 2. So let's see. And then pass. Okay. System dot out dot println. Hello. All right, so let's debug this. Oopsies, we don't have any thingies. So we'll just debug right here. At this point, shit. Wait. Next. Okay, great. How about like this? Okay, how about this? What do you mean, bro? Yo, what the flip? Uh, oh, is that an error? Oh, that's why. Right. So when we do extend here in path, so we create a new list of, so zero to length. Yeah. Location. Okay, so we look at path one over here, and it's going to have a length of 0. Nice. That's great. And it also has no location. Oh, because extend returns something. It doesn't do anything. So we can just say path one. So if we go to path one, has a length of 2, but for some, and it has locations. 0 and 0 is null. There you go. Conditions I. Where are we right now? We're here. Path to dot extend connection to. Why you know? Let's see what happens here. Locations equals locations dot length. So 1 plus 1. It's going to give you 2. So that's going to give you that. And then new blocks. Locations dot length 1 is going to be connection dot get end. And double is going to be okay. New path is going to be with new locks and new length. We return this, so the path, new path, locations equals array, and double equals size. That is weird. The null, that's just null for some reason. Locations I. Why is it doing that? Does it just not do anything in here? While I is less than length. Wait a second. Now path 1 has A and B. Okay, great. So my problem is, okay, we have paths, right? Thing is, how do we use these, the location outgoing connections? It's a list of connections, and I guess location would do that, and then we add a connection to the location. I just don't see how you would use it. All right. Let's try. Okay, so that means if we go over here to do this, let me put a little debugger over there. That means path 2 has length. That's not good. New path A, path 2 dot extend connection 2. What happened? extend connection 2. Connection 2 equals new connection A, C, and 4. What the fuck? It's the same thing I did right here. Or am I done? Connection equals new connection. Connection 2 equals new connection A, C, and 4. And path 2 equals new path with A. And path 2 to extend with connection 2. What the fuck? What did I do wrong? Not good, boys. Not good. Not good, guys. Build a failed. Stop. Bro, what do you mean? Connection takes in A and C, and we have a length of 4. Bro, what the flip? Oh, my bad. Right. So it should be good now. We should have 2 paths. One with that, one with that. So if we create a little priority queue here, import java.util.priority queue. And so then we'll go ahead and be like, say, I don't know, priority queue equals new priority queue of type, how do I do that? Type path like this. Like that. Okay. And then we'll do queue dot add path 1, queue dot add path 2. I'll do system.out.println queue.peak. Queue.peak dot get length. All right. So we should get. Well, so how do you want me to do this? You want me to. So we want the priority queue to have, like, if some shit's smaller, we want that shit in the front. let's try it. Fuck. What the fuck happened? Path cannot be cast to what the hell? Huh. Oh wait, my bad. So we need the path comparator, like that. How do I define a priority queue in Java with my territory class? Okay. New age comparator. New path comparator. Path comparator. Oh, come on, man. I wrote it exactly how you wanted me to. Oh, my fault. All right, let's try it out. Clear. 2. So, yeah, that is indeed what we want. Great. Well, that's only because we added it first, though. What if we add path 2 first? Should it still give us 2? What the fuck? Shit. Path comparator, turn 0, turn 1. What if I do that? What the fuck? What do you want? Oh, man. All right, so if path 1 is... So if we're adding it, all right, so we good now. All right. So, what do we have to do now? Let's see. So finding the shortest path. Now that we have all our helper classes set up, we can set up our main class. The rest of your work for this homework will be done in the Stevens map class. Ooh, I like that. Stevens maps.java. All right. So this class will only contain static methods that represent an hypothetical app for handling all the map operations we would want. start with, we would want to be able to find the shortest path. So we need to implement the shortest path algorithm here. More specifically, we want a shortest path method. The shortest path from start to target. Okay. That's starting and ending at the location. To store our frontier. Damn, Shorty. This is some tough work. I'm not gonna cap. We want the shortest path location, start location, target method to return the shortest path from start to target. There's more than one, it can return any of them. Additionally, containing just the path starting and ending at the start location. To store our frontier, initially containing just the paths starting and ending at the start location. Retrieve the shortest path in the frontier. If it ends at the target location. Understand. I can now use our comparator to make a priority queue. Put all the pieces together. Huh. Oh my gosh. Okay. So, Stevens map. A little confused, but let me keep going. We're at full battery here, so I'm gonna just go ahead and charge my tablet. All right. So create a priority queue to store our frontier, initially containing just the path starting and ending at the start location. Dang it. Hold on. Let me look at the stuff. Connections, Stevens map. All right, so we can have public, static, path. So it's going to return path. Shortest path. Location start and location end. That's going to do something. Return. Okay. Then we'll do public, static, list, location, parse. Okay, that's a whole nother thing. Parse file. Static list. So we got to import list real quick. Import java.util.list. And probably import file as well. Import java.util.file. Was file our own class? Probably isn't. Import java.io.file. Turn no. And public static void main string args. All right. So shortest path literally is the whole algorithm. It's just some lines and a while loop, probably. So let's figure it out. All right. So I guess it doesn't take in any fields. We want to be able to find the shortest path, so we need to implement the shortest path. Location target. Okay, so location start and location target. Which returns the shortest path from start to target. If there's more than one, you can return any of them, and if there's none, more specifically, let us revisit the exact algorithm. Create a priority queue to store our frontier, initially containing just the path starting and ending at the start location. So I guess we can just have priority queue here. Import priority util priority queue. And so go ahead and do to store our frontier. Store location. Store our frontier. We can say queue. Just go ahead and steal that from app. Util priority queue. Path P equals new path start P. All right, cool. So we have our priority queue here, and we have a path, and it's just start, and we have p.add. So that is it. Retrieve the shortest path from the frontier. Add connection, add connection. So all these locations are going to have connections. So all of these are going to have connections. All right. So let's picture this, right? So we have location A. All right, so we got A and let's say B. That's going to be 10. And we have that, and we have that. Okay, interesting. Then A and C. So we have a new variable C with connection 20. Then A and D with new connection 3. Then B and C with connection 5. Then B and D with connection 12. Then C and D with connection 8. What the fuck? With connection 8. C and E with connection 20. And then C and F with connection 25. 25. Then E and F with connection 60. Dang. All right. So that's the whole map. We can restructure it to make a little more sense. All right, we can have A, B, C, D, and then like E and F. Is that the one given in the diagram? Yeah. All right, so hold on, let me draw that. So we got C, D, A, and B. So A, B, C, D, A, and D. Okay, what the fuck? There was never a 3. There was 3. B and A is 10. B and D is 12. B and C is 5. D and C is 8. A and C is 20. And then we got E over here, and F over here, and 20 and 25. All right. So that's our little graph right there. So, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64, 65, 66, 67, 68, 69, 70, 71, 72, 73, 74, 75, 76, 77, 78, 79, 80, 81, 82, 83, 84, 85, 86, 87, 88, 89, 90, 91, 92, 93, 94, 95, 96, 97, 98, 99, 100, 101, 102, 103, 104, 105, 106, 107, 108, 109, 110, 111, 112, 113, 114, 115, 116, 117, 118, 119, 120, we're going to have a list of locations. And so then we're going to have a priority queue. We start with just Q, with just P, which is just A. So we just start with A. And so then you would add show you the shortest path in the frontier. So now we'll do a while loop. While I gotta go piss. Be right back. I'm gonna take a little break, a little apple eating break. I'll be right back. In like probably like 8 minutes. Alrighty. So let's keep cooking. Good looking. See what time works for me. Best. Well, I guess my answer doesn't matter. We're gonna do it at 1 to 2. It's when I'm supposed to eat. So I guess I'll just do this. Anyway, so let's get back to it. So while Q is not empty, I assume, while Q dot is empty, oops, I don't know how that happened. We can go ahead and put that like that. While Q dot is empty, well, it's not empty, we're going to retrieve the shortest path in the frontier. Create a priority key to store frontier. Okay. If Q dot peak dot get, it's a path, right? If Q dot peak dot get end dot get name equals target dot get name, then we good. Then if it ends in target location, then we're done. Then we done. If it ends in a location that we've already visited, move on to the next shortcut. A location we've already visited. So I guess that's what the Boolean in location is for. And so how do we set that? Boolean set visited. If Q dot, so if it ends in location, okay, so if dot end dot is visited equals true, then we'll continue. add the extended path to the frontier. Otherwise, mark this location as visited, and for each possible way of extending this path, add the extent. Otherwise, mark this location as visited. Else, q.peak.end set visited to true. Yeah. And then for each possible way of extending the path, add the extended path to the frontier. Okay, so then now we'll do a while loop for, how do we use the iterable? Otherwise, and for each possible way of extending the path, add the extended path to the frontier. Target.get name. Else q.peak.getEnd.set visited to true. All right, so otherwise mark this location as visited, and for each possible way of extending this path, add the extended path to the frontier. So we have to iterate. We have to iterate through the get end connections, and then make a path, and then add that to the queue. So how do we use this iterable? How do we use I could just use an enhanced for loop. You can call this method and iterate over the returned iterable connection like this. All right, so I can be like, fuck, what did I just do? What the hell did I just do? I can go here and I can do for connection, right? Because that's what location is made out of. It's made out of connections. Yeah. Going connections. So, and then we'll also have a path. New path equals just do that. Say for connection, connect in p dot get outgoing connections. We can be like new p equals new p equals q.p dot extend connection dot extend connection. Type shit. And then we're gonna do new p dot or q dot add new p. Great. Then you want a shortest. Okay, if it ends in Repeat steps 2 and 3 until we find the shortest path. 2 and 5. 2 through 5. We done. Guess we can continue. So how do we continue? I guess we just take out the first thing in Q, right? So we could do Q dot pull. When we add that thing, then all we got to do is be like, if Q dot peak, then what do we return? We return that path. Return Q. Return P. Okay. Until the frontier has no more paths left. So then we could just, return null, literally. Wow, so we had that right. Now, however, we can fill out the details. We can use the methods to impact by having implemented all the steps. Building the algorithm just is putting the pieces together. All right, so let's test this. So in order to test the code, it helps to have a test code whose answers you know. As such, for the example map given in dummy locations, the following are some shortest paths along with their lengths. So we can say that how do we use this? We can just do this. Why not? Path. No, it's the map. So we just throw these all in here. Cool. And then we can call total length 11. So we can call path P equals shortest path with the start, we can say A and C. And we can do system.out.print ln P. Let's hope this works. Let's pray that this works. All right, anyway, P dot get length. All right, moment of truth. Damn. You know, it's never going to work on the first try. You know, it is what it is. Now we got to figure out what the frick went wrong. She. So if it is visited, shortest path A and C. lengths. Let's see if P is even defined. It is. It just is not working. Turn P. Hold on. Hold on. P is never updated. If Q dot peak. Q dot new P. Wait, we're right there. We're right there. Hold on. Hold on. Bro, we're right there. Hold on, bro. Hold on. Return P. Return Q dot peak. All right, now let's try it out. Get another moment of truth real quick. See if we are Gucci. E to F. Yo! Oh my gosh, what a good feeling. Am I wrong? Holy fuck. A to E. Nah, this homework was light, dude. We cooked, baby. Oh my god, we cooked. All right, we totally cooked. We cooked so hard, bro. I'm about to report to the professor. He's gonna be so proud. Reading. All right, now let's finish it up. Let's end strong. I'm gonna get water. That was too lit, bro. That was crazy. I'm gonna be right back. So let's read the file. By this point, you should have tested your code quite a bit, and if you tried making your own maps, you probably have gotten tired of manually setting up all the locations and connections. Thus, our next step is to be able to efficiently set up such maps. That's when we'll be able to write all the places and connections in the file and load them in the program. In the parse file function, outputs a list location based on consider file. Such a file consists of 4 parts. File format such as and names, and connections. Of the connections is the most complicated part here. Each connection is given as a triple of 3 numbers. All right. All right, so pretty chill. Let's see, how do we read a file? How to read a file in Java. And we'll also go ahead and download this jaunt, throw it in. Location, connections, test input.graph, test input.tasks. What do you mean tasks? So I'm not sure where these go. Using buffered reader, using a scanner. We'll do a scanner, whatever. Import java.util.scanner. Java.util.scanner. And then we could just literally just copy and paste this code. I'm not about to learn how to read a file in Java from scratch. So parse file, wait, that's weird. Wait. So we already have a file. That's just what we're gonna give it. All right, so scanner. New scanner. File. So it should be good like this. I don't see what the issue is. We have to return that shit. So while scanner has next line, read the file line by line. Line equals scanner.nextLine, system.out. All right, so we don't need that. Scanner.close, close the scanner, and yeah, we'll catch that error. Catch file not found exception. We'll comment that out for now. We'll keep it in. All right. So anyway, so we'll say while scanner.has next line, So we can do it like this. We can be like int count equals 0. So the first line is line 0. So we can say if count equals 0, we'll say string scanner next line equals scanner dot next line. And so we're going to have a list location return equals new list, just like that. Equals new list, cannot instantiate type list. List of, what the fuck? We'll figure that out in a moment. So we'll do if count equals 0, string line dot scanner equals next line. So we'll say int n equals 0. And we'll just say n equals int line, or we'll say how to turn a string into an int. Let's say integer dot parse int line. Cool. And so then we'll do n equals integer parse int. Cool. Then we'll do continue. Then we'll say if count is less than or equal to n, because we have 6. We'll do 1, 2, 3, 4, 5, 6 here. Line 7. I guess we can do this instead. Say line. Shit. Or we could say line number. And then we could say line number. So if line number is less than or equal to 7, so 2, 3, 4, 5, 6, 7. Then we're going to do what are we going to do? We're just going to have an array list. We'll do like location array equals new location, like that. Oh, fuck. Whoa. All right, fine. Array list, fine. Are you happy? All right, fine. What are you talking about? Oh, shut up. All right, so if line n is not equal to n plus 1, then we're going to do, we're going to make a new location. And so we're going to say the location new L equals new location, and we'll give it a string name. If next line, string line equals scanner dot. Is the line defined here? No. So we'll say string line equals scanner dot next line. Scanner dot next line. We could literally just put line right there. Okay, and then all we have to do is do return dot add new L. Cool. All right, so then we'll do continue. Then we'll say if line, oh my gosh, what did I do? If line, did my shit end? Again, no, it's still good. If line, what the hell happened? If, all right, fuck off. If line n is equal to, let's say, 9, no, fuck. If it's equal to n plus 1, right? So if it equals 6, so it gives us 6 here. So that means that at this point, we're on line 7. 1, and we also have to do int n equals 0. So that would be 7. But we have line 1, 2, 3, 4, 5, 6, 7. So if line n equals n plus 2, then we'll say int m. So we'll just do this. M. And then we can just do else. Finally. Because all we have left in the file is this. So we'll go ahead and do a connection. So I assume a connection will be index that with that. It's going to be that. And will always be non-negative integer. All right, so we're gonna say, so how do I give a location a connection? Location, get name, add connection. So we'll just do add connection. That means we have to create a connection. So we'll say, oh shoot. Fuck, that's annoying. That's so annoying. Oh, you dickhead. So we have to, oh my God. Okay, so we have to find the indices, the indexes of these spaces, then parse the numbers, then create connection. So we'll say int n1, int n1 equals 0, int n2, or we don't have to define them. We'll say double n3, and so we'll do string line equals scanner.next line. Now I have to get the indices. So how do you given this as a line? I'm just going to ask ChatGPT. Given this as a line, can you turn them into numbers? Ooh, that is genius. All right, so we're gonna say like that. Boom, boom, boom. First number equals integer out parse int part 0. Okay, easy. Like work, no reaction. I have to piss again. Be right back. Almost done clapping this. All right, so let's create a new connection. How do I do this? Connection, new connection equals new connection. So we're gonna go ahead and give it, let's see, return dot get first number, return dot get second number, and third number. I bet. Now, now we just have to go to do this. C.add connection. What will it say? Return dot get first number dot add connection. New connection, and then also connection dot reverse type shit. Return dot get second number dot add connection, new connection dot reverse type shit. All right, so cool, and that's it. Then we close it. All right, cool. Then we're gonna return this. Return. List. How do I return list location? I don't. If I have an array of, how can I return the type list location? What the fuck? List location. How the fuck do I return that shit? What if I do something silly? List of return. Can I turn in? Bro, what the? How the? If it's an interface, why do I have to return an instance of it? I don't get it. Allows duplicates. Bro, how the fuck, bro? What do you mean? What? Alright, you're fucking with me at this point. Okay, thanks. Wait a second. Oh, we're good. Okay, good. Anyway, so now, okay, M is never defined. Why is M never defined? We don't care about M. Honestly, so it's whatever. All right, so we have 9 connections. Yeah, your parse function, which must live in your Stevens map class. With appropriate content connections. Bro, we gotta do file, freaking error checking. Oh my gosh. The file is not found to meet the proper. All right, I'm just gonna not do that. I'm just gonna see how he does it. Well, oh, fuck, I'll do it right now. Fine. File is not found. Not being in the right range. What does that mean? Cannot properly be parsed into a map. Okay. Or a connection having invalid endpoints. What does that mean? Invalid endpoints. Also, like index out of bounds. If M1 or M2 is too big or too small, then return null. All right. So, give me a sec. So, I do I put a file in main, in source file, in source folder, or in the main directory. Read it. All right, so let's put it in the main, so we can just throw that in there. Cool. Just give it the maps. All right, so how do I make a file object? Wait, I know how. Test input graph.txt. Then we'll do list location equals, locks equals, what's it shit called? Parse file with file. My bad. So now I'll go ahead and do this right here. Whoop. P equals shortest path, locks dot get index 0, and locks dot get index index so A and E, so 0, 1, 2, 3, 4, 5. A, B, C, D, E. So E is index 4, right? All right, so let's go ahead and print that. Please work. Bulk. No such file or directory. I can't invoke because that shit is null. Test input graph.txt. Where do I put that shit though? Test input dot into test. It's right there, bro. It's right there. Shit. Test input graph. Test input graph.txt. I bet Steve will let me pee. I don't know. Do I put in source? I guess so. All right, so from A to E, we get 31, baby. We parse that file. A to C, that is 0 to 2. That's 11 right there. What can I say? E to F, that's 4 to 5. What can I say? What can I say? What can I say? I'm just too cracked at it. Anyway, so I guess, why are you making us do that, bro? I guess we should trim it. Man, get out of here. Putting it all together, now that we finally have a user-facing program, we want a program that can load. Oh my god, this is so stupid. But we're almost done. Oh my god, this is so stupid. I gotta freaking piss again. All right, I'll look at this in 2 seconds. I gotta go piss again. I'm a boy, let me piss. Let's get straight back into it. All right, let's go. Putting it all together. Let me ask my buddy a question. Bradley, I can't wait to see your smile. But I have a question.
Yeah.
If you go to Canvas and you look at your next 284 homework, what is it?
Okay, I'll check. You mean like what specific assignment it is?
Yeah, like what's it called?
Okay. It's called Test List Q. List Q.
Wait, can you look at the PDF?
Yeah, it's list Q.
Okay. I don't know what that is, but the other class has a different homework.
Well, mine is homework 3-2.
3-2.
Yeah, so they might have homework 3-1.
Maybe. I just finished the homework. I just did it right now because I'm so boss and smart. Uh,
But you have to do the homework if you're TA for the class.
uh, it just helps me understand it better, especially when I haven't ever had the homework. That's the annoying part of being a TA.
Okay, yeah, that is very annoying.
But at least this homework was pretty chill.
Okay.
All right. I'll see you during food at some point.
Okay.
All right.
Goodbye.
Oh, I forgot to unmute. Anyway, putting it all together. Now that we finally have the infrastructure in place, we can put it all together, writing a user-facing program. We want a program that can load in arbitrary maps, and then get the shortest path between arbitrary. I fuck this shit. I'm gonna look at it later. The fifth task. Alright. So we're gonna put this away. Now, yo, whoever's in chat right now, I'm gonna call Mama. And then. I so I'm gonna go ahead and do some stuff. I might as well share my screen. And I'm gonna put on some chill music because we're not gonna do anything intense. We're just doing some logistical, shallow work. Let's put on some of the. Yo, I don't know what this is. So, uh, your specific appointment is on what day? Rise in second years. What else can we add here? I don't know what else.
Yes. I don't know what else I can add here. Next up, that's the bottom. Go to the previous slideshow. Good morning. Quick question. For the class registration slides, you said you wanted to add something. Do you think I can do that, or?
No, you can probably do it. I don't really know what. I was gonna edit it tomorrow morning when I'm waiting for my flight because I'm not there. So.
What are you thinking? Just like a class? Okay. All right. Keep it up. But have a bad night. Let's see. I guess I can throw some tips here. I think 3 classes from other subjects from RCS as other schools. Forgive me, I'm not naive. I've been here before. Your picture, I don't know what else. Yeah, bro. My gosh. I'm going to go head out to my dorm. Just to do all this shit. So yeah, I'm gonna go pop out to my dorm. Honestly, I'm gonna do it. I'm be right back.
Hi. So I'm literally just gonna like do these slides and like look at some companies. So I'm gonna just end the stream here. 'Cause I'm just go back to my room and do this. So yeah, I'll see you guys. Thank you for tuning in, mom and dad, and anyone else. All right, see you guys.